All right, gang, welcome back. Again, still in lesson 1, polynomial division. In this part of the video, we are going to go through the synthetic division. So this one is easier as far as the steps go. There's an extra piece at the end. And a quick reminder, the divisor for synthetic has to be linear. It cannot be anything else. Now, it can be a 2x plus 7. It could also be an x minus 4. So as long as it is a linear divisor, then you can do synthetic. Remember, you can always do long division. So if that's your go-to, go-to. You're going to take a little bit longer. That's okay. You'll do so much of it, you'll become a rock star with it, and you'll be fabulous. All right, let's continue on with this. So in our synthetic division, we are basically going to take our division box that we do for long division, and we're going to do it upside down. I'm going to draw a box this way. I'm going to put the coefficients of the polynomial inside of the box. Okay, and then after I get the coefficients in there, I'm going to look at what I'm dividing by. So if, let's say I'm dividing by x plus 4, then to get the divisor value that I want, because I'm only using the coefficient values, then I need to set it equal to 0 and solve, and that would be the number that I put on the outside. Okay, so my divisor gets set equal to 0 and solved. I'm only using coefficients of the polynomial, and what's going to happen every single time is the first coefficient is going to come straight down. Let's say that it's a 2. It's not going to be a 2, but let's pretend. Then you're going to go through your process. Multiply the outside terms, multiply them. Whatever that number is, add it to the next column. So this gives me a -8. So I would do plus a -8, or I can just do -8. Then I'm going to combine these two values. Let's say I get -1 here, okay? Then I'm going to do that again. I'm going to multiply the outside terms, -4 by -1, and I will add that value, which is +4, to the next column. And I'll figure out what value that gives me. Let's say it gives me a 0, okay? Then I would do it one last time because I've got one more term. The final value that you get is going to be your remainder, if you have one. All right, so if I do -4 multiplied by the 0, let's say that that gives me, oh, that has to be 0, but let's say I had a different number up there, and let's say that my remainder works out to be like 3 or something like that. Totally fine, it can happen. I mean, it is what it is. So that would be a 0 and the other would be a 3. So then you are going to use these coefficient values that we get down at the very bottom. That's what you're going to use so that you can write your polynomial. So if I start with an x cubed and divide through by an x, that'll leave me with a 2x squared, and then minus an x, plus 0, and then plus the remainder over whatever I divided by. All right, so that's a quick little walkthrough with not even a real true problem. So let's try some problems first. Here we go. All right, first example. I want you to always double, triple check. Is the divisor linear? Yes or no? Yes. Check. Good. So I'm going to set that equal to 0 and solve. It'll give me -5. So -5 is on the outside of my box. And then I'm going to take the coefficients of the polynomial, the dividend, and put it inside. Make sure you're not missing any terms. As we had to do with long division, do the same with synthetic. So I have a 3x squared, -13x, minus 10. The last number that I have from the polynomial is where I personally draw a little box and make myself a note that that is my remainder, so I don't forget it if I have one. Okay, so there's our setup. We're good to go. We are always going to bring down the very first term, bring down that value, And now we are going to multiply the outsides. Negative 5 multiplied by 3 is negative 15. And we'll add those two values together to give us a negative 28. I'm going to do that again. I'm going to take the outside terms. Negative 5 and negative 28. I'm going to multiply those two together. That gives me positive 140. I'm going to add that to the next. And that gives me my remainder of 130 when I combine them. I really think that this one was supposed to be a little bit different. I think there's a typo somewhere in here, but it's not a bad problem to practice with. So if your notes say something different, then just know we would have done different values. All right, so how do we write the answer? I took a 3x squared and I divided it by an x. So my first term has to be a 3x. Okay, so for our quotient or the answer, what you're going to do is take the coefficients that you got with your remainder, if you have one, and write them with the variables. So I had an x squared, I divided by an x, and it gives me an x. You're dropping the degree one value. So my first thing will be a 3x. The next one is not going to have a variable, minus 28. And then, unfortunately, because this is crazy, I do have a remainder, plus my remainder, 130, over my divisor, x plus 5. There you go. There is our answer, or the quotient. Again, I think that we might have rewritten this in class. I'm videoing after we've done the lesson, and I don't remember what we changed or how we changed it. So I have a feeling that we changed this negative 13 to be a positive 13. I think that might have been it. Okay, so if this is what we have in our notes, we're great. I'm going to go back through and show you the problem again if it was a positive 13. Eek! Watch all this. Here we go. Eek! This is all going away, and we're going to see how it works. It's still going to be the same process. We'll get a completely different answer, though. Oh, I didn't need to actually subtract that, but that's alrighty. So let's make a change. Let's say that this is a positive 13x, positive 13x. Okay, so now the coefficients of my polynomial are 3, positive 13, negative 10. That's the last term, so I'm going to box that off for my remainder, just in case. Let's see what happens this time. What we are dividing by is an x plus 5. When we set it equal to 0, we get negative 5 as the value. Okay, how do we do it? We bring down our very first term. That represents a 3x squared. So now I'm going to have a 3, one term less, 1 degree less with an x. I'm just going to tuck it there to remind myself. All right, multiply the outsides. Negative 5 multiplied by 3 gives me a negative 15. If I add that to 13 in the next column, I get, that's right, a negative 2. All right, do it again. Multiply the outsides. So negative 5 multiplied by negative 2 gives me a negative 10, positive 10. Whoopsies, I almost made a mistake. Positive 10. Ah, yay. So in this case, I do get a remainder of 0. All right, so again, I started with a 3x squared and I divided by an x. I'm dropping the degree of each of my terms 1 degree because I'm dividing by a linear factor. So our quotient, or our answer, in this case, if we change that middle term, will just be 3x minus 2 because the remainder is 0. Yay, great. So you saw it with a remainder and without a remainder if we change the problem. Remember, we chatted about this in the previous lesson. If you have a remainder of 0, it means that the divisor is a factor of the polynomial. Okay, just extra info. Yay us. All right, let's continue on. Number 4, negative 7x cubed plus 3 plus x to the 4th divided by negative 7 plus x. All right, that is all hecka all over the place. I'm going to rewrite it. X to the 4th minus 7x cubed. I don't have any x squared terms, and I don't have any x terms in the numerator, so I'm putting in placeholders of 3 for those. and then I'm dividing that by the divisor of positive x minus 7. There we go. Okay, I just needed to see it a little bit better. All right, so when I set x minus 7 equal to 0, it tells me that 7 is my value on the outside of my box. That's my divisor. I'm going to use the coefficients of 1x to the 4th, negative 7x cubed, 0x squared, 0x, and then positive 3. 3 is where my remainder is going to happen if there is one. First term, bring it down. All right, real quick. I started with an x to the 4th. I'm dividing by an x. This should be 1x cubed. Each degree is going to drop down 1 as I divide. Okay, so now we're going to multiply the outsides. 7 multiplied by 1 is 7. Add that to the next, and it gives me a 0. Okay, keep doing that. What is 7 multiplied by 0? Yep, 0. Oops. All right, do that again. 0 and 0 gives me, woohoo, 0. Yay. Multiply again. I get another 0, and 0 plus 0 is 0. And then finally, one last time, 7 multiplied by the last 0. Again, that gives me 0, but 3 plus 0 does give me a remainder of 3. So our polynomial, x to the 4th minus 7x cubed plus 3 divided by the x minus 7 as our answer, our quotient, is 1x cubed plus the remainder, 3 over x minus 7. There you go. I didn't have any x squared terms or x terms or any just constant values. That was a little strange. It works. Moving on. Example 7, same type of info. I have x squared minus x minus 30 divided by x minus 6. Okay, here we go. So setting the denominator or that divisor equal to 0 gives me positive 6. And I have 1x squared minus 1x minus 30. Fill in my box for my remainder. First term comes down to give me 1. Multiply the outsides. 6 multiplied by 1 is 6. Add it to the next column. Negative 1 plus 6 is 5. Multiply the outsides. 6 multiplied by 5 gives me positive 30. Add it to the last column, and that gives me another remainder of 0. Yay, thank goodness. So that means that x minus 6 is a factor of the polynomial x squared minus x minus 30. Cool. All right, but what's our answer? What's the quotient? If I started with an x squared and I divided by an x, I'm just going to have an x and then plus that constant plus 5. There you go. So it's 1x plus 5. Cool. All right, continue on. Number 6, 12x cubed plus 2 plus 11x plus 20x squared. That's way out of order. Divided by 2x plus 1. Okay, now in this case, that is linear, but the leading coefficient, your a value, or your slope, if you want to think about it like that, it equals 2. So in all the other ones, it's just been a 1. So in this case, if you're a die-hard long division person, do long division. I'll show it to you. If you want to try synthetic division, stick around. I'm going to show you how it works. It's a smidge different. You have an extra little step, okay? So when we determine our divisor, I have to take 2x plus 1 and set it equal to 0, and that's going to give me, subtract 1 divided by 2, so negative 1/2 is what is going outside my box, okay? I also need to rearrange my terms, so I need 12x cubed plus 20x squared, and then plus 11x, and then plus 2. There you go. All right, so there's the remainder if we have one. Alrighty, first things first, bring down the first term to give me 12, multiply the outsides, negative 1/2 of 12. What's half of 12? 6, so that would be a negative 6. Okay, negative 6. Add that to your next column. 20 minus 6 is 14. All right, what is negative 1/2 of 14? That's right, negative 7. So then I'm going to put in a negative 7 in the next guy, and excuse me, when I combine those, 11 minus 7 gives me 4. Okay, and then I got one more step. Multiply negative 1/2 by 4. Half of 4 is just 2, so negative 1/2 of 4 is negative 2. And lo and behold, thank goodness, we get a remainder of 0. So 2x plus 1 is a factor of our polynomial. Yay, okay? That's not the final answer though, and here's the reason why. We have a leading coefficient of 2, and if you'll notice, every single one of those terms in our quotient in the green that we got, the 12, the 14, and the 4, they're all divisible by 2. So I do have to divide them all by 2 because of that coefficient. So divide everything through by 2, and that would give us a 6. Oopsies, let me change my colors so that we can keep everything straight. So our quotient is going to be a 6, a 7, and a 2. Now we're going to put our variables with it. So quotient or answer, we started with an x cubed, so we're going to drop down to an x squared. So our first term is going to be 6x squared plus 7x plus 2 with a remainder of 0. All right, so that is how you can do this even though your leading coefficient is not 1. If you have a linear factor, you just take that leading coefficient and divide through each of your terms in the very last step. All right, for the diehards, I don't want to remember that extra thing. Synthetic is crazy and weird enough as it is. So let's look to see what happens. Do we get the same answer? Let me go ahead and write that up here. 6x squared plus 7x plus 2. Provided that I don't make any mistakes, if we go through and do long division, we should get the exact same answer. So let's erase, try this guy again, and see if we get the same stuff. Now remember, you can always, every single time for division, polynomial division, you can always do long division, always. But sometimes it just takes a little bit longer, whichever one you get used to for these linear factors. Alrighty, back to this guy. So I'm going to take 2x plus 1, that's my divisor. My dividend in order is 12x cubed plus 20x squared plus 11x plus 2. And off to the side, I look to see what's 12x cubed divided by a 2x. That gives me a 6x squared. Alrighty, so I'm going to put a 6x squared up here, and I'm going to multiply. Remember, we had to multiply the outsides. 6x squared by 2x and by the 1. So that will give me a 12x cubed plus 6x squared. And then we got to change those signs. Here they go, minus and minus. The x squared terms eliminate, thank goodness. Or excuse me, x cubed terms eliminate. And then 20x squared minus 6x squared is 14x squared. Bring down the next term, plus 11x. Alrighty. So off to the side, what is 14x squared divided by 2x? That is 7x. All right, so plus a 7x, and then multiply 7x by the 2x and the 1 to give you a 14x squared plus 7x. And change our signs to subtract. First terms, exact opposites eliminate. 11x minus 7x is 4x. And then bring down your positive 2. Off to the side, what's 4x divided by 2x? That's right, it is just 2. Yay! So plus 2 up at the top, multiply that to give me, oopsies, a 4x and a positive 2, and when we do subtract, changing both of those signs, we do get a remainder of 0. Okay, did we get the same quotient? Yeah, of course we did. Psh. Heck yeah. Same value, 6x squared plus 7x plus 2. So whether you like long or synthetic for this example, you have a choice. I've shown you both ways. All right, that is it for the lesson, both long and synthetic division. Make sure you're practicing some. Hit me up if you need help with anything. Bye, guys.